Point 13, trig limits, part 1. In part 1 today, there's going to be 3 types of strategies we can use to try to figure out trig limits. And the trig limits will always be as x is approaching 0. I included the graphs of sine and cosine just as a refresher that as x comes to 0 in the sine function, y value is 0. And in cosine, as we come to 0, y is actually 1. Okay, so with direct substitution, those are obviously the easiest. You can just plug the x values in and simplify. This one would be that -4 times sine of 0 over 7 cosine of 0. Sine at 0, sine of 0 we said is 0, so that would be -4 times 0 over 7 times cosine at 0 is 1. So it'd be 7 times 1. That would be 0 divided by 7. Doesn't matter because 0 is on top. So our answer would be 0. All right, you go ahead and pause and try number 2. Since cosine of 0 is 1, I plugged it in right here. 4 times 1 is 4. -10 plus 4 is -6. And then we have 3 times 0 minus 1, which is -1, divides to get 6. So pretty straightforward. Type 2, you're learning a new identity for limits. Sine of x over x is always equal to 1. I put this in on Desmos and graphed it, and look, as you're approaching 0 of this function, it approaches 1. Okay, so I know you won't have the graph, but you need to put this in your brain. That sine of x divided by x will always equal 1. So your job is going to be to break apart these limits using the limit properties to try to get this foundation in there, and then know that that simplifies to 1. Number 3, I'm going to get a highlighter here to help a little bit see it. So number 3, I see a sine of x over x, but the x is being squared. The first thing I like to do is actually take out any coefficients, kind of factor them out, pull them out in front. So I would have 7/8 and then times my limit as x approaches 0 of sine of x over x squared. And then I can work on, well, how do I make this have a sine of x over x? Well, I'm going to split this limit into 2 limits, have 7/8 times the limit as x approaches 0 of sine of x over x times, put times here too, limit as x approaches 0. Sine of x over x, what would we need to multiply that by to make it sine of x over x squared? Well, we don't need anything on the numerator, but I would need another times x, right? Sine of x times 1 is sine of x times x is x squared. I just split it using properties. And then what I can do is look at, here is my foundation here, that sine of x over x is really, that's a 1. So I have 7/8 times a 1. And then this would be, once you break this apart and I plug in 0 right here, I cannot have 1 divided by 0. That is a does not exist. And again, as soon as we get a does not exist for one piece, I can't do anything else. That would be a final answer of does not exist. So there must be some oscillating behavior or something, some kind of jump at that x is 0 in that function. All right, number 4. I again almost see sine of x over x, except for I've got a sine squared. First, let's take out this -10, so we don't even have to really deal with it until the end. And then I'll have times my limit as x approaches 0 of sine squared of x over x. This time I don't want the numerator to have that squared anymore, so I'll make a fraction that has sine of x over x. Then I'm going to have another piece that is just sine of x. You can put it over 1 if you want to, but see, I'd have sine squared of x over x. And don't forget about your -10. Okay, so this piece, my bracket's not good, sorry. That would be a 1. And then plug that in. What is sine of 0? What do we say that is? Sine of 0 is 0. So -10 times 1 times 0. All that work to find out our limit is 0, but it does exist at least. All right, number 5. We've got 2 terms here with x. Let's look for a GCF in the numerator. Let's see, 28 and 20 can both be divided by 4, and I can take out a sine of x from both terms. So then I would have a 7 sine of x. Kind of don't like the parentheses, they seem to add confusion to my brain. And then minus 5 over 4x. Okay, I can take out, let's see, divide a 4 by 4. It's just gone. Let me write this better. I would have the limit as x approaches 0 of sine x times 7 sine x minus 5 over x. I see what I need right here. So I'm going to split this limit into 2 to have my sine of x over x times just another 7 sine x minus 5. This is 1 times, let's do direct substitution. Sine of 0 is 0, 7 times 0 is 0, minus 5 is negative 5. 1 times negative 5 is negative 5. Will be our answer. And on the next page, type 3 is now a trig or a limit identity with trig function cosine. 1 minus cosine of x over x approaches 0. So it's kind of funny how that's opposite. Like cosine at 0 is really 1, well now it's 0, and sine at 0 is really 0, well then that identity had it equaling 1. I graphed it so you could see it, that as x approaches 0 in this function, it does have a y value of 0. But remember this identity as well. So we're trying to do the same thing and break this up. Number 6 is pretty straightforward where I almost see it, but I also see that those 9s are in my way. So I'm going to factor a 9 out on the numerator. I'm going to factor out or pull out that 9 halves in front. And so I'll be left with 1 minus cosine of x over x. And this, we said, is 0. And 0 times 9 halves is 0. Okay, number 7. We have, I see x over cosine of x minus 1, so it's reversed. Let's look at that one. Really all we can do is pull out this negative 3. So we'd have negative 3, and then our limit as x approaches 0 of x over cosine of x minus 1. There's nothing else we can do. We can't break this limit apart. Can't do anything, so let's do direct substitution. See what's going to happen if I plug a 0 in here. Cosine of 0 is 1. 1 minus 1 makes it 0. So the denominator would be 0. When this happens, this is a does not exist. So you might want to make a note to yourself that if you have x over 1 minus cosine of x, that's a does not exist for the limit as x approaches 0. All right, and then number 8. You should be able to identify that you do have the identity right here. 1 minus cosine of x over x. We just have to figure out how can we get that split apart. Well, the top is all addition and subtraction, so it's not as easy to split apart as multiplication is, but we can still do it. Let's group together the 1 minus cosine of x. It'll be over 10x still. We're going to keep this common denominator, and so we need to make another term that would be plus the 5x. So let's put plus the limit as x approaches 0 of 5x over 10x. Okay, and if you're totally confused on that, think back to adding fractions. Ignore the limit stuff. If I were to put these fractions together, I would keep the common denominator of 10x, and then I would have 1 minus cosine of x plus 5x. So different order than what it originally appeared as, but same thing. So with adding and subtracting in the numerator, you have to keep the common denominator in both fractions when you split them. Okay, so in this one, I don't like the 10 being here, so I'm going to factor out or pull out the 1/10 times the limit as x approaches 0 of 1 minus cosine of x over x. And then in this one, I can simplify, and that becomes a half. So really, I can just have plus, I'll put the limit, and I'll show you what this does, is x approaches 0 of a half. When you have just a constant function here, think of that as like a y equals a half. That would be this guy. So no matter what x value I'm approaching, I'm always at a y value of a half. So this would be 1/10 times, we said this is 0. So that would make 0 plus a half, which would be a half. Okay, so there's part 1. We'll do part 2 next.